So in this video, we're going to learn about composite functions. Composite functions. And these include g of f, g of g, f of g, and f of f. Then alongside composite functions, we're going to learn about inverse, because the two concepts interact. Inverse of a function. Then apart from the inverse, we also learn about domain and range. I'm deriving this from the example, the paper that you're seeing here. So this is an excerpt of a paper from the University of Nairobi, Calculus 1. It's normally a common unit in almost all the universities in the world. So whatever you're seeing here is these are component functions, composite functions, and then of course we'll do this example and see how these composite functions work, and then of course now the inverse stuff comes in, and then later on we'll finish with domain. I'll give rules on how you find the domain of a function. I'll give rules on how you get to determine, even without calculations, what is the domain of that function. So allow me clear this. So that we start off from this question. So let me just minimize this size. So we have this. We're supposed to solve whatever we've been given. So we start off by first outlining the functions. So f of x equals to 1 over x minus 4. G of x equals to 3x plus 7. And then h of x equals to cos of x minus 1. So whenever you're given such a function, so these functions here, so we learn about composite functions. So the first composite function, when you're told to find f of g, what this means is that where there's a function f of x, this time around its x is g of x. This is what it means. This also means that f of f implies that where there's a function f of x, the x is f of x. That's what it means. Similar to g of f implies that it is g. Now where there's x, you replace with f of x as a function on its whole, on its entirety. Then same thing applies to g of g. This implies that there's a function g, but now the x is g of x. So now, even without solving the questions we've been given, so allow me solve this first. So let's first try and find the composite functions even before we do anything else. So let me change this pen and change something else. Yeah. So let's find f of f, that is of x. So this is when you replace where there's a function f, but where there's an x, you replace with f of x. So in this case, we have 1 over, so where there's an x, you put 1 over x minus 4, then minus 4. So you notice the position of x the position of x here was replaced by the whole function f of x. Where there is an x, you replace with the whole function f of x, and then you solve. Okay, so let's solve this and let's see what we get. So the LCM here is 1. There is so x minus 4, 1, this is 1 minus, this is 4 into x minus 1. Sorry, let me just write clearly. This is x minus 1. So therefore, this means that this is 1 minus 4. Okay, let's just close it. X minus 4. Then divide this by x minus 4. What do we get? We open this numerator. We open the numerator. We get 1 minus 4x, then plus 4. All this divided by x minus 4. So we proceed and say. So now let's continue. So next thing, let me change something else. So next thing, what do we do? So this equals to, so 1, collect items here. So 1 plus 4, this is 5, then minus 4x, all this divided by x minus 4. So this becomes f of x. So let's proceed. We are supposed to find again, let's see if we can find what do we find? Let's see if we can find f of g. See if we can find f of g. So f of g, we change into a different pen. So f of g of x will be given by, there's a function f, then what you replace it, you put g of x inside where there's an x. So this means that f of g will be 1 over, we have an x here. What is our x? Is g of x. So it's 1 over g of x, then minus 4, which gives us 1 all over 3x plus 7, then minus 4. So this goes without saying that this is 1 all over 3x plus 7 minus 4, that is 3x minus plus 3, and this is f of gx, which in other words we are calling it f of g of x. So that's it. Let's see if we can find, we can solve also g of h. Then, I mean, now you're getting the concept. So the concept is replacing where there's an x, you put the function that is you're actually trying to find. So having solved that, at least now that you understand what is happening, let's try now go back and do the questions. Let me just delete this. Just delete this. Okay. So now we have our question here. Let me just do away with this. So our biggest question here is the domain of f and range of f. So f of x is given by 1 over x minus 4. So the domain of f, so domain will be given by, the rule is anything 1 over n is such that n is not equals to 0, because 1 over 0 will always be equals to undefined or something, not really infinity. It should be infinity, yeah. 1 over 0 is undefined, but this cannot be a domain in this case. So what we're supposed to do is, so what is our n in this case we're having is x minus 4. So this goes without saying that the domain here will mean that x minus 4 should not be equals to 0, which therefore means that x should not be equals to, so we take negative 4 to the other side. That means x should not be equals to 4. So this is so normally they'll ask you whether you give it in interval notation or you give it in this is in interval notation or inequality, in a form of inequality. So this is inequality, but now in interval notation, what this means that let me just illustrate this. So from negative infinity to infinity, this is our 0. So please, x cannot be equals to 4. So that means we are including everything until here, and then also everything here, but not this area. So this area is an abomination because that's where our domain is not defined. So that means that our domain, so our domain will be anything from negative infinity, but please, when you get to 4, don't include it. So we are putting this. This is a sign of non-inclusion. But if we did this, if we put a parenthesis, now this is an inclusion sign. But in this case, what you are saying is, now that 4 is not included, we are not including it. So this means now you don't include 4, but you also join that with where 4 starts, but is not included, to infinity. So this is the domain of f, nothing else. Now let's proceed and see what other question were they asking. The other question was what was it? Sorry, let me just put it there. Yeah. So they're asking the range and the range of f. So domain, range of f. Okay. Let me see. So range of f of x. So we have 1 all over x minus 4. That is our function. So the easiest way to get a range is supposed to be the exact, you substitute all values in the function, and that we said in the domain. So this area here, let me just explain. So all the values that you said are in the domain, because we said x cannot be equals to 4. So anything 4 will not be in the x. So that definitely means that if you substitute 4 here, 1 over 4 minus 4, you get 1 over 0, which is undefined. So how do you get range therefore? To me, my easiest way was to find inverse, but in this case, I'll show something better. So we can draw that and see by first substituting some few values, and you get to see what actually happens in range. So you want to get range of 1 over x minus 4. So what are these values? How do you draw this? So when x is 1, what is y? So let me illustrate this in a graph, in a drawing. So this is our y-axis, this is our x-axis. So we said there is an asymptote. There's an asymptote, a line which the function never touches. There's a vertical asymptote at x equals to 4, because we said x cannot be equals to 4. So this function looks this way. It comes from negative infinity as it narrows down to